You see the tutorial? This is tutorial sheet. I'm only take the question from tutorial, question 5, 7, 8, and 9. Okay, clear? Clear
Yes,
tutorial questions? Okay, so we're starting now. In question number 5, ask to find the optimum tilt angle for a south-facing solar collector in Texas. Given latitude equal 31.1 degree at solar noon on 1st of March. So find the optimum tilt angle. We're starting from symbol. We know we have many angles, depends on sun, on collector, and with respect to earth. So we have many angles. Now, in this question, given find the optimum tilt angle, given the symbol of tilt angle. واحد يعطيني نوت. Tilt angle, symbol, epsilon. Tilt angle, we'll see in other, okay, in lab or in other lecture, tilt angle have 3 names. For same angle, there are 3 names called tilt angle or elevation angle. Otherwise, we can say it as inclination angle. So 3 names. أكتبهم بعد شوي, okay? So epsilon called tilt angle or elevation angle or inclination angle. وكلهم هم الثلاثة means زاوية الميل. زاوية ميل البي في with respect to other. Okay? اللي هي زاوية ميل collector BV. Okay? For given now with respect to south facing, with respect to solar collector in Texas. Latitude, given symbol of latitude, we see this angle before in question number 4. Latitude, level 4, lambda. Okay, at solar noon, this is important note, at solar noon. Time at solar noon? شو يعني solar noon? At 12 PM, okay? الساعة 12 بالضبط. هنا تكون أكبر قوة ممكن تكون موجودة للشمس. The sun will be with respect to collector to BV. How does كيف تكون solar at solar noon the sun with respect to collector to BV كيف تكون؟
تكون عمودية.
عمودية perpendicular maximum radiation will be at noon solar noon. أعلى قوة الإشعاع تكون موجودة على البي في at noon. فبتصير في هاي المكان at solar noon اللي تكون perpendicular with respect to collector. Okay, and given date at 1st of March. So we need to find the tilt angle. I will draw this question in a small diagram. So we have collector, okay, in the face of south. لو كان بالنورث كنت أرسمها بهاي الشكل. بالنسبة للنورث بهاي الاتجاه. احنا نتكلم عن south facing. So with respect to south facing in this direction. So south. Okay. Now at this point, this is the collector. Now given at solar noon. So the sun will be perpendicular with respect to collector. فبتكون بهاي الاتجاه عمودية على القيمة اللي موجودة. Okay. perpendicular بزاوية 90. ممكن طبعا تكون اللي هو الري اوف سان ممكن ارسمه في هاي المكان، شخص ثاني يرسمه في هاي المكان، في اي مكان، ولكن هو يكون perpendicular. لو اخذه بهاي الشكل فاذا هو بشكل عمودي. اوكي، في اي مكان with respect to collector at solar noon will be perpendicular. Okay. Now also we have other note. I will sketch only one ray. Depends on sun, so will be perpendicular in this example in this side. Okay, so we need the tilt angle. Now tilt angle with respect to direction. tilt angle هي زاوية الميل بالنسبة للهوريزونتال. فالحين أنا الهوريزونتال عندي بهاي الاتجاه. Okay, this is the horizontal line. Okay. So tilt angle will be here. This is the tilt angle, which should be fine. Okay, this is the tilt angle. We need to find epsilon in this case. If we know the ray of sun will be perpendicular with respect to collector, with respect to BV in this case, so this angle will be 90. Okay, with respect to vertical axis, this is vertical axis, will be perpendicular, angle 90. So how to find tilt angle? كيف ممكن أوجد tilt angle? I will give you extra one note. Okay, the angle between the ray of sun with respect to horizontal plane called altitude angle. Okay, altitude angle different than latitude angle. We have latitude angle lambda, but altitude angle, symbol of altitude beta. Beta, that means the angle between the sun ray with respect to horizontal plane. So this is the angle beta between sun ray and horizontal plane. If we know this value equal to beta, where beta altitude angle equal to 90 minus lambda, where lambda latitude angle, then plus delta. Anyone remember delta? We see delta before in more than one question. Delta called declination angle, where delta depends only on number of days. إذا تتذكروا هنرجع لها باك اكتب القانون. فإذا depends on number of days, we have date, so we can find delta. Lambda given, so we can find now beta. If finding beta now, how to find epsilon from this diagram? Okay, we have two angles now. We have beta, we find beta in this case. We have angle 90 in this place, so we need epsilon. How to find epsilon? From symmetric of angle. تذكروا الزوايا التناظر والتماثل. How to find epsilon? Where's epsilon will be? In this side. Because in this side now, in this side, if we see from this side, we have this angle 90 and we have beta. We find beta. So if we find now this angle, we'll find the epsilon. So this is from symmetric of angle, this is epsilon. قوانين التناظر هاي هي قيمة الإبسلون. So if we have beta and we know this angle between the vertical and horizontal angle equal to 90, so epsilon will be epsilon
90 minus
90 minus beta.
Okay, so 90 minus beta. So this is the idea to find the optimum tilt angle. So I will written now the meaning of beta first. So beta called altitude angle. Altitude angle. Okay, and beta equal to 90 minus lambda plus delta. Now, delta called declination angle. Anyone remember rule of declination angle? Declination angle 24 or 23.45, then sine of 360 over 365.25, okay, times d minus 80. We see before this rule, where d number of days, okay? Some reference given this value as a d minus 81, approximately same. So we can find now d. D, the number of days. How to find number of days? We have date given on the 1st of March. So should we find D? So step number 1 should be find delta. When finding delta, then we can find beta. When find beta, then we'll find the tilt angle. Okay? Now, anyone know the number of days? D equal to how many days? How to find it? We're starting from January. So
31 for
31
January
from, yes, from January, then
plus 28 from February
28 or yes, or 29.
plus
So
1 for March.
and first day from March. So the number of dates equal number of days
60 days.
50,
60.
60, yes, 60 days. So we'll substitute now to find delta. So delta will substitute in rule. So delta equal 23.45 sine of 360 point over 365.25, then substitute by D equals 60, then minus 80. So this answer all of angles given in degree. So should be find in degree. Find delta, declination angle.
$7.9 miss.
Plus minus. Yes, 7.9 should be negative.
Minus
Check.
7.9.
Minus, yes. So minus 7.9 degree. So this is the angle of delta. Now we can find beta, altitude angle. Therefore, beta will be, substitute now in rule, 90 minus lambda given equal 31. Yes, given 31.1 in the question, 31.1. Then plus delta, where delta in negative sign, so minus, change plus to minus, so minus 7.9. Minus 7.9. Please given the answer of beta.
$51 degree.
Yes, 51 degree. Then the last step. Now, therefore, I will give you the name of epsilon first. Epsilon called 3 names. We'll see in lab. Tilt angle or elevation angle. Otherwise, we can call inclination. Therefore, in this case, in this question, epsilon will be 90 minus beta. So will be 90 minus 51. So angle, tilt angle,
39 degree.
yes, 39 degree. So this is solution of question number 5. Any note? Okay, clear?
Yes, it is clear.
So a question number 8, same as this question. Okay, same, given same question. Find the optimum tilt angle for south-facing photovoltaic model in Sohar, Oman. Now different only in latitude. This is always constant, lambda, constant for each place. So in Sohar, latitude equal 24 degree. This is lambda. Okay, so lambda equal 24 degree. At solar noon, on 2nd of April. So now the difference between question number 5 and question number 8 only in angle, latitude, the value of latitude and the value of number of days. All steps will be same. So number of days from given date, we'll find this value. I will give you the final answer. So we're starting from finding D. So D will be how many days? From January? Starting from
29
January.
days.
So 31 January, then plus 28 from February, then March, how many days? 31 from March, and we need from April, how many days?
2 days.
2 days from April. Then the number of days will be
92.
92, yes. So 92 days. Then can find now delta. Step number 2, find delta. Depends on delta, okay? Depends only on number of days. So will be 23.45 sine of 360 over 365.25 times day minus 80. So delta will be, when substitute, will be 4.81. 4.81. You know the rule, so delta will be this angle. Then we'll find beta, where beta equal 90 minus lambda, lambda given equal 24, then plus delta. We'll find answer equal to 70.81. Then the last step should be find the optimum tilt angle or elevation angle. So tilt angle will be 90 minus beta, so equal to epsilon
19.19.
Yes, 19.19 degree. Clear? We can solve. Same as the question number 5. Okay? If these two questions clear, we'll back to question number 7 now. Okay? We'll go to question number 7. This is the question. Calculate the solar insolation on horizontal collector at a latitude of 24 degree on 20 of February 2017, and given two cases at equinoxes, at also at equator. Okay, so we're starting from question. Calculate the solar insolation. What does it mean by solar insolation? Find what? Insolation means the power density of solar radiation. So we'll find the power density of solar radiation. Given the unit of power density, should be in which unit? Solar insolation, that means the power density. Power density unit in watt per meter square. Yes, solar radiation. Should we use power with respect to area? So watt per meter square. We'll see also this note in lab, okay? So we have horizontal collector. Should we know the type of collector? Because we have 3 types of collector. Given in this question, horizontal collector. Anyone know the 2 different types? We have 3 types of insulation collector. The first one on sun tracking surface, other one on stationary surface, and the third type on horizontal surface. So we are now in case on type number 3, given horizontal surface. Depends on the type of collector, we'll find the value of solar insolation. باختلاف التايب of collector, the 3 types of collector, القوانين تختلف how to find the power insulation in watt per meter square. I think you see now this note in lecture note, because finish the module now. or still today you will finish?
Yes, miss.
Okay, so this note given in week 3 in this lecture of this week. So depends on this type now, depends on this type in the question 7, we have horizontal collector. Given latitude, this is lambda, equal 24 degree, and given date 20 of February at equinoxes and at equator. Okay, so we need to find now power density of solar radiation. What is the difference between at equinoxes and at equator? We see before at equinoxes. Equinoxes means هذه عند الاعتدال اللي هي at spring and autumn فصلين الربيع والخريف. At equinoxes. Anyone remember the value of declination angle at equinoxes? We see before. We
0.
divide it 0. 0. Yes, equal
Yes,
0.
miss.
Yes, before we apply the note of declination angle from previous question, we see this note delta. This is declination angle equal this rule. Now, if we are in equinoxes, so delta direct will be 0. So at winter or at summer, so it is. We're starting from summer. At summer, the delta direct should be no, equal only 23.45, and this value, the term of sign of this bracket will be 1. So will be 23.45 at summer soytist في الانقلاب الصيفي. Otherwise in winter soytist will be same value but negative, minus 23.45. Okay, so at equinoxes delta equal 0, but we didn't need now in this case the value of delta, because power insulation in this case at equinoxes will be depends on latitude angle. So for part number 1, okay, for equinoxes, the power solar insulation will be BS over by cosine lambda, where lambda latitude angle and this value given. So we'll substitute direct. For second part, we need at equator. At equator. So at equator, the value of solar insulation P equal to, anyone remember rule? Depends on which angle. We have many angles. Depends on what? On declination angle. So will be PS, same rule. And cosine also same, but different, we'll use different angle. And equinoxes will depends on latitude angle, and equator will depends on declination angle. So PS over pi, then cosine of declination angle delta. We can find delta depends on only number of days. So we have number of days from given date equal 20 of February. So we'll find this 2 answers. Clear? Now we need the value of angle we have. Okay, we can find delta, lambda given direct. But how to substitute by PS? What does mean by PS? Not given in a question. P, you know, all symbol of B means power. So this is power density now. Where's the value of power density? We didn't have any note in this question about PS. How to find it? How to find power density? Anyone know? BS means the power density, and the power density on sun, the power density on sun equal, okay, PS, only note, the power density on sun equal 1360 watt per meter square. Okay, this is on sun. Okay, now when power density from sun radiation, this is radiation now, يبدأ الإشعاع from sun will reach to atmosphere will reduce by 360. So power density at atmosphere من توصل إلى الاتموسفير بتفقد جزء من الراديشن اللي هو 360 so will be 1000 watt per meter square. So this is the value of power density which uses now in this case because now reach to atmosphere. So this is the value of power density. This is constant now. هذه قيمة ثابتة أستخدمها من توصل من الشمس اللي هي radiation كمية الإشعاع اللي توصل من الشمس إلى الأتموسفير. Then PS and two lows given in at equinoxes or at equator BS this is constant equal 1000 watt per meter square. Okay, so now direct you can find the two values. So in case one the insolation will be BS where BS 1000 watt per meter over by and cosine of lambda where lambda equal 24 degree. Find solar insolation. Now pi in this case equal what? Equal 180 or 3.14. We have 1000 over pi.
180.
180. This is out of angle. This is constant. Should be used 3.14. Constant. Not inside the bracket. Not inside. Not with respect to cosine and sine and so on. So this is constant. So pi equal 3.14. This is constant. هذه قبل الangles. فإذا high constant equal 3.14. So find now the power insulation in watt per meter square.
290.
Okay, then 0.7, yes. Unit will be watt per meter
square.
Yes. In case 2, at equator, this is not BS. I'm written in incorrect. This is only B. BS equal 1000. So this is B, the solar insolation. So B at equator, again, equal 1000 over by and cosine of delta. We didn't value of delta. We didn't find this answer still till now. So should be find declination angle first. So declination angle to find delta should be find what first? To find delta.
Number of days.
So number of days depend on given date at 20 of February. So D equal to how many days? From January, 31 days. Then
Plus 20.
plus 20 days from February.
It is
So
51.
equal 51 days. So 51 days. So we can find now delta. Apply rule will be 23.45. Okay, sine of 360 over 365.25 times D minus 80. We know D now equal 51. Substitute in this rule, then find delta.
Minus 11.2.
Minus
11.2.
yes, equal minus 11.2 degree. Yes. So we'll substitute now in rule of solar insolation would be 1000 over pi cosine of declination angle. So minus with sine minus 11.2 degree.
312.2.
300, yes, yes.
12.2 watt per
300,
meter square.
12.22.
0.22.
Okay, 0.2 watt per meter square. Okay. Anyone remember this angle? What's called this angle? Alpha? Alpha called which angle?
Our angle.
Our angle, yes, our angle. In this case, if given this type of collector, horizontal collector, so alpha at equinoxes, anyone know alpha, our angle, equal to what? We know at equinoxes, delta equals 0. So alpha, it's not given in lecture note. At equinoxes, alpha equal pi over 2. Okay, so 90. Alpha equal 90 and delta equal 0. This is at equinoxes. At equator, delta depends on number of days. So we find it. In this case, equal minus 11.2 alpha. In this case, if asking another question, the value of our angle at equator, also this value equal pi over 2, 90. Will be 90 again, pi over 2. Please read the lecture note. Many information given in lecture of week 3, I mean. Okay, so clear this question? Okay. If you have any note or question, ask please. Before moving to last question, question number 9. See in lecture note, if given other 2 types of collector, how to find the rule or the note, how to find the insolation power or radiation, solar insolation. Okay, should be know the rule. If given in exam, given same question with other type of collector, should be know which rule should be applied. Okay, this is given in this week lecture. So we'll go now to last question, question number 9. In question number 9, we see before question number 4, same as this question, but now with extra 1 part. If back to question number 4, I will back to question number 4. What is the question? This is tutorial. Okay. You see tutorial? Clear? Clear the tutorial sheet?
Yes.
Okay. So in question number 4, we solved before last hour. Okay. Find the azimuth angle for the sun at 3 p.m. solar time in Colorado, given latitude 40 degree on summer soil test. So now in question number 9, see question number 9. Find the elevation angle. This is extra 1 part. Okay. And azimuth angle. So if starting from azimuth angle, solve or find the azimuth angle for the sun at 3 p.m. So same as question number 4. Solar time in Colorado, latitude same, equal 40, also on summer soil test. So question number 4 and question number 9, same. Extra 1 point given here in question number 9 to find the elevation angle. Okay, so before, if back to question number 4, I'll give you a note to remember the solution before. لما حلينا question number 4 before, in question number 4, when asking to find the azimuth angle Okay, how to find azimuth angle? We used before this rule. Tan of zeta, azimuth means zeta. So tan of zeta equal to sine of alpha over sine of lambda cosine of alpha minus cosine of lambda and tan of delta. Anyone remember the angle, the azimuth angle was in this question? Minus 80.
minus 80.
Yes, minus 80. We solve and find in question number 4, minus 80, okay? So, in this question, we'll solve again, but we'll use other rule, depends on now elevation angle, which find in previous part in this question. So in this question, we'll solve two parts. Part A will find the elevation angle, okay? Then we'll find azimuth angle in part B, depends on elevation angle. لاحظوا هنا in question number 4, first given the symbol of elevation angle. شنو نرمز لها elevation angle? We see elevation angle in question number 5 in this tutorial. The first question, elevation
Epsilon.
or tilt or inclination, epsilon. Yes, elevation angle, epsilon. So if see the rule of tan zeta, which using before in question number 4 without epsilon, we use this rule, okay? And when use this rule depends on our angle, latitude angle and declination angle. So without elevation angle. Now in this question, we need to find again using other rule, okay? Depends on epsilon. So we need to find same angle, should be find minus 80, okay? واضح السؤال؟ طبعا in exam solve using any note, okay? So we can now in this question you can solve direct using the same rule which find in question number 4. But for our note, because now given elevation angle, we'll solve using elevation angle. And the rule of elevation angle easy to apply to find azimuth angle. So we're starting from elevation. Okay? So part A, we need to find now elevation angle. How to find elevation angle? This is the rule of elevation angle. So we'll use sine of epsilon equal to long rule cosine delta cosine lambda cosine alpha, then plus sine delta sine lambda. So we need how many angles? We need delta, lambda and alpha, 3 angles. So any angles given in this question? We need to see the given data. Yes, given latitude. So latitude equal 40. Which angle this one? Delta, lambda or alpha?
Lambda.
Lambda. So lambda direct given equal 40. Also, we need alpha and delta. We don't have number, the date to find the number of days. So how to find declination angle delta? We see before, we find delta, okay, in question number, I don't remember, in question number 5, I think, and question number 8, we find number of days depends on given date. Now we didn't have a date. So how to find delta? Now delta given direct from where? Because given now in this case on summer soil test, we see before, it's given summer soil test. So delta direct equal 23.45, yes, direct, because given summer soil test. So we need only to find now number of, we need to find our angle. How to find our angle? Our angle depends only on time, yes? So our angle alpha equal to, if you remember the rule, equal to 360 over 24, and this value constant equal 15. So 15 times t minus 12 in degree. In lecture note given in degree and in radian, so all angles will be in degree. So this is for degree. Now we have time. Yes, given time equal at 3 p.m. So 3 should be used out of 24. Should be used time out of 24. So 3 out of 24 time instead of 3 will be
15.
15. Okay, out of 24. So will be 15. So will be 15 when substitute by time. So 15 minus 12. Okay, we know 15 minus 12 equal 15 minus 12, 3. Yes?
3.
So because given now, we have other note. We have other note for our angle. We have two notes. The first note should be used time out of 24. So we use it. Then the second note should be check. Should be check the time will be before noon or afternoon. If afternoon, we'll use this value as a negative, otherwise will be positive. So we have 3 p.m. So afternoon. So will be positive or negative? Afternoon. Negative. So will be 15 times minus 3. So our angle equal
Minus 45.
minus 45 degree. Okay. So we solved before only for remember now this case. Okay. So we can substitute now. So we need to find epsilon. Please substitute. Sine epsilon will be cosine delta. So cosine of 23.45. Then cosine of lambda equal 40. Then cosine of minus 45 plus now sine. Sine of delta, where delta 23.45 again. Then sine lambda, where lambda equal 40. Find this answer, then we'll find elevation angle equal arc sine of this value. So sine of epsilon will be note here. Then epsilon will be arc sine of this answer. So find epsilon, elevation angle.
$48.49.
40, I will check. Yes, 48.82.
827.
49.
0.9,
48.
0.9,
No, 0.49.
0.49, 0.5, yes? So
Yeah.
depends on rounding here will be different. Some students will find 48 point, I hear 48.9. Also I
Yes,
hear
I found
48.4 or 48 point something. So 48, this is the angle. Point, okay, depends on the rounding. تعتمد على التقريب اللي استخدمته هنا. فمثلا أنا عندي 48.82. Other students will find other answer. So given the final answer 48.82.
82.
82, okay. 82, okay. 82 ولا 28؟
82.
82.
82, yes. So this is epsilon. Okay, this is the elevation angle here. Now the second part B, now we need to find azimuth angle, not for using same rule which finding before in question number 4. So I will give you the other note, other rule using epsilon. So in part B, we need now to find azimuth angle zeta. Azimuth angle zeta. So we'll use, in this case, sine of zeta will be cosine of delta, then sine of alpha over cosine of epsilon. We need now to substitute by epsilon. So when substitute, please should be find zeta equal minus 80, same as question number 4. Okay, so cosine delta equal 23.45, then sine of minus 45 over cosine of 48.82. So zeta will be arc sine of this angle, of this value. So zeta
minus 80.14.
okay. So zeta will be minus 80.14. Okay. So equal same value when using the two different rules. Also, we have other rules, depends on cosine. We can find using cosine or using any other rule. So it depends on given data, should be choose the easier rule. هم كلهم الrules صحيحين, ولكن depends on given data. If you have the value of delta, you have the value of alpha, and so on, should be use the rule which find depends on the given data. So in this case, in question number 4 and question number 9, we find azimuth angle same value, equal minus 80, approximately minus 80. Okay. Any other note or question? Now finish this tutorial, this module. All question after question number 9 given with answer.